So we had a couple gentlemen joining us here from Houston, Texas, the energy capital of the world. Alex Lach and Andrew Pruet here to talk about how they're leveraging LLMs, MongoDB, and some AI for their searching of text PDF documents, land documents. So excited to hear their story and welcome to Austin, guys.
Thank you. So yeah, we're here to talk about the unreasonable effectiveness of KISS. KISS standing for Keep It Simple Stupid. And basically we're just going to talk about a process we built that saved us many millions of dollars via replacing some contractors. And this was at Oxy. And before we get into that, real quick on Oxy, if you haven't heard of us, we're basically the biggest oil and gas company in the US that does not have a gas station, is probably the simplest thing. But we have three segments. One is upstream. This is where we would actually produce oil and gas. We have a chemicals division, and we also have a low carbon ventures group doing things like direct air capture, carbon sequestration, and other initiatives like that. Okay, so getting into this. This presentation probably won't be quite as impressive as a feat pulled off about 30 years ago by some friends in the industry. Not going to an asteroid, not drilling a hole in it, not dropping a nuke down that hole and saving the world. But similar to these guys, we are just some petroleum engineers. And we're here just to walk through a very simple solution using Mongo, some AWS services, some off-the-shelf language models, and how we use those to make many millions of dollars for Oxy. So yeah, my name's Andrew Pruet. I went to school here at UT studying petroleum engineering. Interesting fact about me, I have a very low tolerance for spice, like spicy things. I think black pepper is about as spicy of a thing, an ingredient you need in this world. Beyond that, I just can't do it. Oh, sorry.
Yeah, and I'm Alex Lach, and I'm obsessed with tiki cocktails. If any of y'all have time tonight, I highly recommend Tiki Tatsuya, just a little bit south of here. Before I kick off, I just want to say our team is all about going fast. So as you're watching this, you might be looking at the architecture diagram or thinking, like, wonder why they did it that way. Maybe there's a better way. You're probably right. Really, we went into this with zero Mongo experience, and what was amazing for us is we were able to get something up and running in a matter of days rather than weeks or even months, and it worked really well for us. So we're excited to share that story with you all. So today, I want to talk to you all about our document problem, but not this kind of document. I want to talk about this kind of document. This is a land lease agreement. This is a contract that governs how Oxy gets to use the minerals under the land, the oil and gas under the ground. And these, you might be looking at this, you say, oh, it's just PDF, what's so bad about that? But then I would show you this one, which you might say, okay, that's a little bit worse. It's got, mix of handwriting, text, whatever, it's a little harder to read. And I'd show you this one, newspaper clipping. Then I'd show you this thing, or this one, or this one, or even this guy. So you start to get the idea, maybe these documents are kind of in bad shape. And, but then again, you'd say, like, okay, it's just some documents. How long could it take? You sort through them. Might take a little while. You get through it. But Oxy's been in business for over 100 years, and so we've accumulated a lot of these documents. This is one aisle in one of dozens in one file room, and Oxy has dozens of file rooms. So for scale, that's me at the back of the aisle there. And yeah, so with the land documents, we've accumulated over 12 million of these. And you can imagine there's departments, there's teams, there's hundreds of people that use these documents every day. And they're not always paper, they're usually scanned in. But even once they're scanned in, it takes a lot of effort to get what you need, to find the information you need among millions of land documents. So this project came about because Andrew and I got wind of a major effort. It was supposed to kick off April 1st of this year to scan in and deal with 1.5 million of these land documents. So what they wanted to do, they were going to hire a small army of third-party contractors to scan all these documents, to read the documents, categorize them into one of the 140 categories, and then to extract some basic information out of these documents to go in our land system. And this is to support a much larger business process that I'm not going to get too much into. But this project, again, 30 external contractors, budget of $4 million, timeline of 18 months. And Andrew and I were talking about this. We were thinking about this. We're like, there's a better way. There's got to be a better way. And we said, what if we could replace this army of third-party contractors with an army of lambdas? And of course, language models were all the rage. You know, we've been experimenting with them for a few other applications, and this seemed like a perfect use case. Read a document, classify it, extract some information out of it. So Andrew's going to walk you through some of the mechanics of how this works.
Yeah, thanks, Alex. Yeah, so getting into the architecture, as Alex mentioned, we start with basically just these paper documents. They get mailed into us. Once we receive them, we'll scan them in. From that scan, we'll generate a PDF. This will go to FileNet. This is our ECMS. And then we also have a SQL Server taking in some of the metadata off that scan. So this would be things like, you know, when we got the file, who it came from, or who sent it. Nothing really about, no information from the document itself, so nothing internal to the document. Very simple stuff. And really after this step is where the contractors would come in, and they would start reading, classifying, extracting. And just to mention it, this piece right here, this box, this is highly integrated amongst several other systems at Oxy. So we really, our scope was not to attack anything in here. We don't have much control over it. The timelines for changing anything the way stuff is done in here would have been enormous. So instead what we did was just ship all this stuff to our own AWS environment. So really simple, basic way of doing this. We wrote a Python script to start reading docs and dumping them into S3. Once they're in AWS, we can really do whatever we want, build whatever we need to around it. And here we kind of hit much more of like an event-driven architecture. So you get an object create, that object create sends a message to SQS, and then we have a Lambda function waiting that's consuming from that SQS queue. And we run tons of Lambdas concurrently. Because remember, we're talking about many millions of documents. A given Lambda here might take 20, 30 seconds to run. And we're trying to do this in a reasonable amount of time. So we run lots of Lambdas at the same time. And as far as what the Lambdas are using for their information they need to do this processing, we need some of the metadata. These will just be some ML features we use over in the Azure cloud. And then we also need the document itself. So the Lambda is going to pick up that object from S3, load it up, and send it off to Azure cloud. Then Alex, you want to take over, talk about this?
Sure thing. Yeah, so you might be scratching your head like, why are they mixing and matching clouds here? I don't have a great answer for that, but I am going to walk you through what's going on in Azure. There are three things we're trying to accomplish. First is we need to do OCR. I showed you some of those documents earlier. You probably got a sense that a lot of these are really ugly. So we knew it was going to be really important to have high quality OCR, optical character recognition. I don't know if I defined it yet, but we did a benchmark. We undertook to benchmark all the major cloud provider OCR solutions, the open source solutions, and some other private paid options for OCR. Traditionally, Oxy has used Kofax, I guess, for scanning and for OCR, and frankly, the quality of that OCR is pretty bad. I have a pretty not so bad example document here, and you can see Kofax for this. Of the 5 things we care about in this document, it got just 2 of them correct. For example, you see Atlantic operating turned into Atlantic gyrating, which is funny, but not what I want in my land database. So we found with our benchmarking the best results with Azure Document Intelligence. You can see with this one, we got all 5 correct, no problems. And this is a really affordable option, out-of-the-box option, didn't take a lot of tinkering on our side. So this is what we went with. And a quick sidebar, the reason OCR is so important here is we're about to get to the fun stuff using the large language models, right? But it doesn't matter how smart my LLM is. If I feed it garbage text input, it's going to have a really hard time making sense of that, and it probably won't be able to do what I need and give me what I need on the other side. So this was really important. I know it's not as exciting, it's not as new, but it's really important. With that, we were able to take our OCR text, and now we need to tackle the first job for the contractors, which was classifying these documents. So these land documents, they could fall into one of 140 different categories, and we were really fortunate with this that we actually had hand-labeled, reliably labeled data for most of these categories. So we were able to take a simple approach. We used an off-the-shelf embedding model, text embedding model, from OpenAI, text embedding 3 large. And we fed the OCR text into that. We get our embedding vectors back, 3072 dimensions. This visual here you're looking at, this is that kind of high-dimensional vectors compressed down into 3D using PCA. And what you can see is it starts to become clear which documents are which in this kind of vector space. We can distinguish between these documents. So all we had to do was train a classifier on top of this. We tried a few different things, ended up with big surprise, XGBoost. We used the embeddings plus some hand-curated features for some of the harder categories. And we did a comparison. We did a kind of a blind test between the subject matter experts, the contractors, and the XGBoost model to see who was the best. And the SMEs were the best. But that's not surprising. We were just a hair under the SMEs, but far, far better than the third-party contractors, the less trained third-party contractors. And of course, much, much cheaper. So we were thrilled with these results. Really, really simple, out-of-the-box tools, gluing them together. It worked great. So we were ready to move on to our next third thing, extraction. So, as I said, 140 different document types. Depending on what type of document we're dealing with, we want to extract some key metadata. The reason we want to do that is because every time we need an answer for one of these documents, we don't want somebody to have to open it up. We want that to be in a database somewhere where it can be queried. It could even be used by an automated system. So we're extracting up to 16 properties, depending on the type of document. Some of these are really, really simple. On the OCR slide, I showed you names, dates, really simple stuff, locations. But some of these are a lot harder, actually. We have some that are legal clauses, terms. Some even require integrating information from a paragraph here and then a paragraph like 10 or 20 pages later in the document. So some of these are pretty complex extractions. And you probably know where I'm going. We use an off-the-shelf LLM completion model. We just were able to do this entirely through, we didn't even have to use multi-shot prompting. We didn't want to because these documents are pretty long. Instead, we just use prompt tuning. And this is a draft prompt right here for our lease extractions. And I know this is way too small to read. The point is not for you to read it. It's just to kind of convey that these prompts get pretty complicated. I think anybody who works kind of in-depth with these systems, something like this, you'll start to see these prompts get pretty elaborate after a while. For us, this was the hardest part of the project, not the technical stuff. The hardest part was like getting these land subject matter experts and kind of shaking them really hard and getting all their expertise onto paper or onto a prompt, I guess. And also, with 1.5 million documents, you can imagine there's a lot of weird edge cases, like really unique stuff from like the 1800s. So handling a lot of those edge cases was really hard. That's how these prompts got so complicated. And our results from this, again, we were just a hair below SME level accuracy, but way better than the contractors on our blind testing. So we were thrilled and we were ready to proceed ahead doing this at scale.
All right. So yeah, we haven't really talked about Mongo yet at all at our Mongo conference. And no, you know, we thought about just trying to use S3. That would have been a bad idea. We're happy we got Mongo on here. So where Mongo comes in, initially what we wanted was just to have Mongo store results, and very simple results. Basically link a physical paper document to a document in MongoDB and have this one-to-one correlation, and that'd be it, really. This would just be kind of a data layer that eventually we would load back into FileNet some of the data and move on. Things got more complicated than that due to some edge cases, and basically what had to happen was our stateless lambdas had to become stateful. And yeah, I wasn't too thrilled with that idea. But again, we are we were trying to move very quickly, and refactoring infrastructure was a lot more costly time-wise than refactoring some code in the data model in Mongo. So yeah, we shifted all our documents to hold a state, and what this would just mean is the Lambda, it's going to go through a process, and Alex talked about a lot of these, so like go gather OCR, do some classifications, get embeddings, do extractions, and each one of these might be its own HTTP call. Each one of these might require some tokens. And so we wanted to kind of track the state of how far a document got so that if there was ever a failure, we could just retry that Lambda and pick up where we left off. So some edge cases that cause this, one is just large PDFs. When we started, 99.9% of our PDFs are probably 1 megabyte, 2 megabyte, maybe some 10 megabytes. Every once in a while, though, you get like a 2 gig PDF that comes through the system. And not to get too in the weeds on Lambda, when you invoke a Lambda function, it is allocated with a certain amount of memory. We try and keep that memory pretty low to save costs. So yeah, when the large PDFs comes through, we do send it to a DLQ and give it a much larger Lambda to be processed with. But even so, if anything goes wrong with that, it's a very costly mistake where we just spend a lot of tokens on OCR, and it'd be a real shame to fail in extractions and then redo that same OCR, pay for that again. So we're keeping the state. We start where we left off on any given Lambda call if the document's already failed once. And this proved to actually fix that edge case really well. The other edge case is this Azure cloud where we're doing all the OpenAI calls. This is a shared resource at Oxy. If you remember from a couple years ago, during really the whole AI craze, getting TPM allocations in the cloud, especially from Microsoft, was difficult to say the least. And there's a lot of competing entities for it, even internally at the company. So what they did was they just stood up a resource and said, all right, AI, ML, SMEs, here's some API keys, y'all can go use these. So yeah, we use them a lot, and we actually try and max out our token allocations to process these documents as quickly as possible. But it's very possible another team comes in and says, hey, I want to try out this solution. I need some tokens. It's going to cause a lot of our Lambdas to start failing because we get token limits. Anyways, we just built the system, hold a state. If 20% of our Lambdas start failing, that's okay. They'll fail really quickly. Try again. Maybe make it through that time. And let's not worry so much about infra again. Has anyone ever put in an IT ticket that took like 6 months to go through? Maybe? Yeah. We didn't want to take that risk. So let's just use what we have, keep going. This worked pretty well. And then finally, one really interesting thing that happened during this on the Mongo side is, and I say this in a complimentary way, we kind of forgot about Mongo in all this. Meaning, we went from making a few requests to MongoDB to making thousands of requests a second to MongoDB. And it never really caused an issue. Like there was a lot going on in my head about, oh man, are we gonna run into Lambda concurrency issues? Are we gonna be maxing out tokens? All these SQL Server calls we're doing, is that gonna be an issue to this on-prem SQL Server? But I kind of forgot Mongo was a big piece of this data layer, and it was just never an issue. And so it was actually one of those rare experiences where something in your tech stack just works without bothering it at all. And it was really pleasant to use. So thank you, MongoDB, for building this. So the results, real quick. First, we saved $4 million, and that was kind of what we were set out to do. And money talks, and mission complete with that alone. 2. Uh-oh. Sorry, we're having 2. We saved a lot of time, saved 12 months. Alex had mentioned the project was originally slated for 18 months, and we took it down to 6 months. And so saved a year of people's time. And then finally, just some technical learnings. I'd say probably the biggest one for us was just realizing that the solution was pretty modular. So lots of areas of our business have documents, PDFs. PDFs where people wish they had a whole lot more information about that PDF than they actually do. And so we were able to just take kind of our architecture, our framework here, lift it, shift it, update some prompts, and from doing that, we actually saved another 2 to 3 million, again, of just don't hire the contractors, we can solve this for you really quickly. And the turnaround on those projects was a lot faster, like 4 to 6 weeks. And then finally, on the MongoDB side, while we basically use Mongo here, pretty much just their core offering. It's a document database, insert stuff, update stuff, read stuff, write stuff. That's what we used it for. It performed wonderfully. We did get to start playing around with like vector indexing. We are storing all our embeddings there. We just haven't done anything with them yet. And also full text search was surprisingly fun to use here. I did a POC, I think just on a late night one night, just static HTML page, a Lambda serving stuff from a full text index set on top of many millions of our documents OCR sitting in Mongo. So we're talking about probably 100 gigs-ish worth of text data and getting probably 200 millisecond retrieval on these text searches I was sending to it. And I was kind of just blown away. It was like, wow, all I did was assign an index to this thing and start sending commands and have kind of a Google search built in a night. So it's really cool. We're excited for what Mongo has to offer in the future. That's probably going to be kind of phase 2 is exploring a whole lot more use cases with some of the more advanced features. So yeah, to close it out, hope you enjoyed this little info session on keeping it simple, our KISS method for approaching this, and happy to take questions.
Is it not on? Great presentation. Can I ask you, did y'all consider the AWS tech extract as opposed to the Azure?
Yeah, I can take that one. So we did. We tried it. With these particular documents on the benchmarks we ran, they were close, but we got better results with Azure Document Intelligence.
Was it going to require more work to train it or whatever?
We weren't doing any kind of training or adjustments.
It was all done by prompt. You didn't have to really have to.
With Textract's like the OCR solution is what we were using it for OCR. So we compared Textract versus Azure Document Intelligence for OCR. For the actual extractions, we couldn't do that with any of those. Those tools weren't advanced. We needed an LLM to do the complicated extractions that we were doing.
Okay, that makes sense to me. And so you had some documents that you said were a lot larger. You know, that they were humongous. Was it because of the quality of the documents? You know, like they had a lot of background noise and they were old, or?
I guess I'm not a land expert, but there are certain, I forget what they call them in land, certain like lease agreements that are thousands of pages.
It's usually title documents.
Title documents.
I mean, but they were because of size, not necessarily because.
Yeah, some of these were thousands of pages.
Yeah,
I would imagine with some of the old documents, like you probably had, was that where a lot of your errors were coming in? That
yeah,
hard to read?
And also in document, like I guess PDFs, when you start adding in, I think kind of what you're alluding to, like some of the granular effects you get in the back, that increases size dramatically. So things like that. There were a lot of things to figure out.
Was that one of your big challenges? Was the quality of those 100-year-old lease agreements or
yeah, I'd say big challenge was the quality of the documents themselves, and then the other big challenge was getting the extractions right, mainly which was getting information out of the subject matter experts.
Did Azure OCR do a pretty good job on the handwriting?
It did an amazing job with
Excellent
handwriting.
job.
Yeah, even cursive, pretty ugly handwriting, it would do pretty well.
And did you have to create different prompts for the different age of documents, one for handwritten versus
We didn't do anything age-based. So really, we're trusting the OCR to get the raw text right. And then as far as the language model is concerned, there's not a huge difference between an old and a new document, except maybe the language has evolved a little bit in terms of the legalese might change. We did a different prompt per 140 different document classes, roughly. Some of them were actually like catch-alls, so it wasn't exactly 140 prompts, but that was where we broke out the different prompts, was on the document class.
Okay. And if you don't mind answering, about how much did y'all end up having to spend on your cost for your
Yeah.
large language model?
It was around 25K.
Oh, wow. That's pretty, and that was for scanning?
That was for all in scanning.
When you say 11 million documents, is that pages or actual, one document might be 10 pages?
So there were 12 million land documents, but this project scope was just 1.5 million documents.
For the 25K, you're saying?
Yes.
Okay.
But a document, like you were getting to, could be 1 pages, it could be 100 pages. So it could be a lot of pages in a document. So yeah, it was less than 1/100th of the cost of running this manually, which is kind of what you would expect. Yeah.
Well, I think this is a great solution, guys. I mean, I've been working with some of this stuff myself, and I think I appreciate your presentation.
Thank you. No more questions? Good. All right. Thanks, guys.
Well, really appreciate it, guys.